So let's take a look at complex numbers in their usual form, which I'm calling rectangular form here. Um, Complex numbers always consist of two parts, a real part and an imaginary part. And we call it the imaginary part because it involves the number I. That's kind of what separates complex numbers from real numbers, okay? Real numbers are actually complex numbers, but imaginary numbers are not real numbers, and they involve the imaginary number I, which is the square root of -1. Now the rectangular form, or maybe the standard form of a complex number that we typically see, is a plus bi. And so you can see there's two parts. There's the a part and there's the b part. A is called the real part. That's the name of it. And that's because it is not the coefficient of the imaginary number I. B, since it is the coefficient of I, is called the imaginary part. Now both of these numbers they're both real numbers. Neither one of them is an imaginary number itself. So these are both real numbers, meaning you can graph them on a number line, okay? So they're real numbers. Now, how do you graph, or how do you think about these complex numbers, a plus bi? Well, since complex numbers consist of two parts, we can graph them in a two-dimensional plane, your typical two-dimensional plane, and we're gonna use the complex plane, which has a horizontal axis and a vertical axis because it's two dimensions. The horizontal axis corresponds to the real part of the imaginary number, and the vertical axis corresponds to the imaginary part. So when we look at our typical coordinate plane, and sometimes, well, let me write it this way, typical coordinate plane, we often will label the horizontal axis as being the x-axis and the vertical axis as being the y-axis. This is what we call R2, because you've got a real number horizontal axis and a real number vertical axis, okay? The complex plane is exactly the same, we just label it differently. So we have a vertical axis and a horizontal axis. We label the horizontal axis as the real axis and the vertical axis as the imaginary axis, okay? So let's see some examples of how to visualize complex numbers in a plane. So what I want to do is graph each complex number in the complex plane. Now it's very common to use the letter Z to represent complex numbers. So I wanted to emphasize that here a little bit. It's very common to do that. In this particular problem, 5 is the real part. It's like the A of the complex number. So the real part is 5, and the imaginary part is 2, not 2i. Not 2i. I is not a component of the imaginary part. The imaginary part is the real number associated with I. So if we were to think about this, what I would do is label my real axis, my imaginary axis, and I would locate 5 on my real axis, so 1, 2, 3, 4, 5, and 2 on my imaginary axis, and I would get this point right here. So this point represents the complex number 5 plus 2i. So we can represent complex numbers as points in a plane. Okay? So let's do the same thing over here. The real part is 3, so 1, 2, 3, and the imaginary part is -4, 1, 2, 3, 4, and so this point represents the complex number 3 minus 4i. Okay? Let's do a couple more that are a bit more unique. Example 3, we've got z equals -6. Well, this can be confusing at first, but think of it as it's the same as -6 plus 0i. The imaginary component is 0. The imaginary part is 0. So when I graph this, I have got -6 on my real axis and 0 on my imaginary axis. So that means this complex number actually lives on the real axis, the real number line. That's because this is a real number. -6 is a real number, not an imaginary number. It doesn't have an imaginary component. So it actually lives on the real number line, the real axis. And similarly over here, we could think of this as being 0 plus 9i. This has a 0 real component. So when I graph this one, I have 0 on my real axis, but 9 on my imaginary axis, which is up here. And so this point lives solely on the imaginary axis because it's a completely imaginary number. There's no real component to it. Okay? So this point is not 9, that's the label on the imaginary axis. This point is the complex number 9i. Alright? And something to note here, it's very important, complex numbers, you can see, behave like ordered pairs, but we don't write them as ordered pairs. We write complex numbers as a plus bi, not as a comma b, okay? So make sure not to get that confused. Even though they behave the same way, we write them as a plus bi when we write them in rectangular form. Now, it's called rectangular form, if we can go back to our prior screen. It's called rectangular form because it deals with a horizontal component, which is the real part, and a vertical component. Horizontal and vertical are perpendicular to each other. Therefore, it's a rectangular system.